1 in 5 deaths in the United States are due to heart disease, and the British Heart Foundation estimates that there are around 620 million people living with heart and circulatory diseases across the world. But what if the causes of heart disease are different from what we have been told? The conventional view of heart disease is that plaque builds up inside an artery, eventually causing a blood clot and a blockage. The blockage shuts off circulation to that part of the heart muscle, and this causes a heart attack. The situation is seen as a basic plumbing problem, and most medical interventions are aimed at resolving the blocked artery. However, during the last 70 years or so, a number of eminent scientists have been proposing an alternative explanation. One of these scientists is the Italian cardiovascular pathologist, Dr. Georgo Baraldi. Dr. Baraldi graduated in medicine from the University of Milan in 1949 and became lecturer in pathology in 1959. Baraldi's early work in pathology was published in multiple prestigious medical journals, and by 1955 he had already received his first award. Dr. Baraldi went on to receive further awards from the National Institutes of Health, the American Medical Association, and the College of American Pathologists. Dr. Baraldi published more than 350 articles on topics such as ischemic heart disease, myocarditis, pathology, and cardiac transplantation. For half a century, Dr. Baraldi challenged the conventional theory regarding the processes associated with heart disease. Dr. Baraldi suggested that heart disease can start first within the heart muscle itself and not in the arteries, as is conventionally thought. Baraldi made a number of observations, such as some people have a significant amount of narrowing of the artery without any signs of damage to the heart muscle itself, and the narrowing could have existed for years without any clinical symptoms of heart disease. Conversely, it is possible to have an area of dead heart muscle tissue without a corresponding blockage in the artery. In fact, he found no relationship between the amount of plaque in the artery and the degree of damage to the heart muscle itself. Another aspect highlighted by Dr. Baraldi was the importance of collateral circulation. In the presence of a blocked artery, the heart adapts by increasing blood flow through the collateral circulation. When describing the anatomy of the heart, it is common to refer to diagrams that show just the main arteries. What we usually do not see in most images is the extent of the collateral circulation. The collateral circulation consists of an intricate network of blood vessels that also supply the heart muscle with blood and oxygen. Therefore, in the event that one of the main arteries is blocked, circulation can be routed through the collateral blood vessels. In fact, Baraldi and colleagues published articles containing ultrasound images to show the extent to which collateral circulation can compensate. The existence of collateral circulation and the inconsistencies between blocked arteries and actual damage to the heart itself could lead us to question if arterial blockages are the main thing to worry about. The hypothesis that heart attacks can start within the heart itself is sometimes referred to as the myogenic theory. Another pioneer in this field was Dr. Mesquita, a Brazilian physician and scientist whose work has been continued by fellow Brazilian Carlos Monteiro, an independent researcher and scientist. If the myogenic theory of heart disease is correct, it means that the most significant cause of heart disease and heart attacks is psychological and physical stress. Let's explain why. Most people are familiar with the fight or flight response. Based on sensory input, principally what we see and hear, and on stored memories, the brain decides if a given situation is stressful or not. If the brain perceives stress, the hypothalamus at the base of the brain triggers the stress response. The hypothalamus sends a signal to the pituitary gland, also at the base of the brain, which in turn sends a signal to the adrenal glands. The adrenal glands then produce hormones such as cortisol, adrenaline, and noradrenaline. As a side note, In the United States, adrenaline is often called epinephrine, and noradrenaline is called norepinephrine. The many physiological changes that occur during the stress response are designed to make the body faster, so that we can either fight or run away from the danger. Even the type of energy that the heart uses changes at this time. The heart prefers to use an aerobic energy system, which converts fats and glucose into energy in the presence of oxygen. This energy system yields more energy, but it is slower to produce the energy. The anaerobic energy system predominantly uses glucose, and it doesn't need oxygen. It produces energy more quickly. It is not surprising that the stress response causes a shift from aerobic fat burning in the heart to anaerobic glucose metabolism, since we need to generate energy as quickly as possible at this time. However, this is done at a cost. The cost is the production of lactic acid. The production of lactic acid can cause the environment within the heart muscle to become more acidic. The heart's temporary shift to glucose burning as part of the stress response probably worked really well for our ancestors and enabled them to deal with an immediate threat. But our world today is very different from the time of saber-toothed tigers and other predators. In today's world, the stress response is frequently and chronically being activated for all kinds of reasons, from being stuck in traffic to having an argument with someone on social media. The repeated or chronic activation of the stress response can cause a significant change in the biochemistry of the heart. The frequent shift to glucose burning and the generation of lactic acid can lead to an acidic heart. The concept of an acidic heart might sound strange. However, scientific articles investigating acidosis of the heart go back 100 years. Acidosis of the heart is highly significant because the acidic environment interferes with the heart's ability to contract. This results in an impairment of blood supply to the heart muscle cells, which could eventually cause their death, which is the very definition of a heart attack. But it doesn't end there. Acidosis, combined with other aspects of the stress response, may cause vascular stretching that leads to damage to the inside wall of the arteries. This happens because acidosis may cause blood vessels to dilate. At the same time, the activation of the stress response causes blood vessels to constrict. This pulling and pushing on the vessels could cause vascular stretching and alter the shear stress within the arteries. The change in fluid dynamics within the arteries could be in addition to changes in blood flow as a result of the damaged heart muscle tissue. Some researchers have stated that changes in fluid dynamics are the most important cause of damage to the inside wall of the arteries. Once an artery wall is damaged, a blood clot could eventually form within the artery, and the repair processes are called into action. If damage occurs repeatedly, then other substances such as white blood cells, cholesterol, and other molecules are sent to the site of injury in order to deal with the problem. The combination of substances now contained within the wall of the artery form a plaque and the characteristic coronary artery disease. If an autopsy is performed on someone who has died of heart disease, a classic blocked artery may be present. But which came first, the damage to the heart muscle or the blocked artery? This is a basic explanation of the myogenic theory of heart attacks. I have included links to more detailed information in the description. I have also written a book about the real causes of heart disease, and a link to that is also in the description. Thanks for listening.